In 1969, one rocket carried 3 astronauts to the moon, landed 2 of them on the surface, and brought all 3 home. One launch. That was it. To send astronauts back to the moon today, NASA's current plan needs somewhere close to 20 separate rocket launches, just to get one lander fueled up enough to make the trip. Not 20 rockets, carrying 20 different pieces of hardware, 20 launches of the same vehicle, mostly just to deliver fuel. That number sounds almost absurd, so it's worth understanding exactly where it comes from and why NASA agreed to an architecture this complicated in the first place. Start with what just happened. On July 25, 2026, SpaceX launched the 13th test flight of its Starship rocket, the vehicle NASA has chosen to carry astronauts down to the lunar surface. The booster, called Super Heavy, flew its ascent and flip maneuver perfectly, but during its final descent toward splashdown in the Gulf, only 10 of its 13 restart engines actually fired, and by the moment of impact, only 5 were still running. It hit the water harder than planned, in what the flight team is calling a hard splashdown. The upper stage, meanwhile, had a much better day. All 6 of its engines fired cleanly on the way to orbit. It deployed 20 Starlink satellites in a real test of its cargo release system, and it even briefly relit one of its engines mid-flight, a capability that future moon missions will absolutely require. It came down for a controlled splashdown in the Indian Ocean about an hour after liftoff, and for the first time, the vehicle stayed fully intact afterward, floating on the water with several of its cameras still transmitting. That relight test matters more than it might seem. A starship bound for the moon can't just coast the whole way. At some point, its engines have to fire again in the vacuum of space, and every successful relight test is one more piece of evidence that the vehicle can actually do what NASA is depending on it to do. But here's the part of the story that rarely gets explained clearly. None of that Starship, on its own, can go anywhere near the moon. Not without help. And that's where the number pinned to this whole architecture comes from. The Apollo program worked the way it did because of one basic design decision. The Saturn V carried everything at once, fully fueled, in a single launch. Astronauts, lander, and enough propellant for the entire round trip, all sitting on the same rocket at liftoff. As former NASA Administrator Jim Bridenstine has put it, the genius of Apollo was its simplicity. Artemis doesn't work that way, on purpose. The astronauts launched separately, aboard NASA's Orion capsule, riding a completely different rocket called the Space Launch System. The lunar lander, a modified Starship, launches on its own, from a different pad entirely. And unlike the Saturn V, that Starship lander doesn't launch already full of fuel. It launches essentially empty, because carrying enough propellant to reach the moon and land, on top of the sheer weight of the vehicle itself, isn't something a single Starship launch can physically manage. So instead, NASA's plan calls for a fleet of tanker versions of the exact same rocket, launched one after another, each one delivering a partial load of propellant to the lander waiting in Earth orbit. A NASA Inspector General report estimated the mission would need at least 15 of those tanker flights. Later briefings from NASA officials put the real number in the high teens, closer to 20 once every contingency is accounted for. SpaceX, for its part, has pushed back hard on those estimates. Back in 2021, Elon Musk called the idea of needing 16 launches extremely unlikely, suggesting a maximum of 8 tanker flights, and floating the possibility that it could take as few as 4. That gap between NASA's public estimate and SpaceX's own projection isn't a rounding error. It's roughly a factor of 4 between the most optimistic and most cautious numbers still being discussed for the exact same mission. Part of why the number is so hard to pin down comes down to a genuinely difficult engineering problem: keeping the propellant cold enough, long enough, in space. Starship runs on liquid methane and liquid oxygen, both of which have to stay extremely cold to remain liquid. Sitting in orbit, exposed to sunlight, that propellant slowly warms up and boils away, a process engineers call boil-off. The longer the lander waits in orbit for its tankers to arrive, the more fuel it loses before it even starts the trip to the moon. That means the tanker launches can't just happen whenever it's convenient. They effectively need to happen back-to-back, in rapid succession, refueling the lander before too much of what it already received, quietly, evaporates away. A recent Government Accountability Office report flagged exactly this issue as one of the program's biggest open risks, singling out SpaceX's cryogenic fuel management technology by name. According to that same report, SpaceX is now more than a year behind its original schedule on several major milestones, including the long-duration propellant transfer demonstration and the uncrewed lunar landing test that has to happen before any astronauts are allowed near the vehicle. And here's the detail that puts the whole picture in context. As of today, no version of Starship has ever actually reached a stable orbit around Earth. Every flight so far, including this one, has flown a suborbital trajectory, up and back down, never staying up long enough to complete even a single lap around the planet. The specific lunar lander variant of the vehicle hasn't flown a single test flight yet, in any form. It's also worth understanding what the full mission actually looks like once all those pieces are finally in place, because it's more elaborate than most people realize. Before any moon landing happens, NASA plans to fly an entire practice run first, in low Earth orbit, without anyone setting foot on the lunar surface at all. Orion will launch with 4 astronauts aboard, then spend roughly 2 weeks in orbit rendezvousing and docking with both lunar landers back-to-back, the Starship variant and the Blue Origin variant. Astronauts will actually climb aboard the Blue Moon lander during that test, but because the Starship being used for the exercise is a standard production model rather than a true human-rated lander, it won't have any crew cabin at all. Just a docking adapter bolted where the living space would eventually go, and the astronauts won't go inside it. Only once that entire rehearsal is judged successful does NASA plan to attempt an actual landing, currently targeted for around 2028, with astronauts descending to the surface near the lunar South Pole aboard the real thing, riding an external elevator down to the ground and back up again, once their time on the surface is done. NASA isn't betting everything on one company's rocket either. Blue Origin, founded by Jeff Bezos, is building its own lunar lander, called Blue Moon, meant to serve as a backup option starting with a later Artemis mission. That lander will also need refueling in space, just closer to the moon rather than in Earth orbit. So it isn't a free pass around the same basic engineering problem, and Blue Origin has its own recent setback to work through. During a recent test firing of its New Glenn rocket's main engines, the launch vehicle exploded, badly damaging its own launch pad in the process. None of this means the Artemis program is doomed, and it isn't evidence that the plan is somehow secretly failing. Big, Unprecedented engineering programs almost never move in a straight line. And orbital refueling, if it works reliably, would unlock a lot more than just one moon mission. It's a capability NASA wants for eventual trips to Mars too, where a Saturn V-style everything-in-one-launch approach becomes even less realistic than it already is for the moon. What this really is an honest, complicated bet. NASA is trading Apollo's brute force simplicity for a system that, if it works, could be reused again and again, launch after launch, instead of building an entirely new throwaway rocket for every single mission the way Apollo did. The trade-off for that reusability is exactly the number this video started with. Not one launch, but somewhere between 8 and 20, depending on whose estimate you believe, all just to get one lander fueled up enough to leave Earth orbit in the first place. Beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel. New episodes on space, physics, and the edges of what we understand, with new content going up every day.